Now we'll see that we have two kind of mirrors. We have two kind of reflecting surface, that is the mirrors. One is the plane mirror, other is the spherical mirror. As it is clear from the name that this must be having a straight plane surface and this will be having a curved surface. So spherical mirror is that which has a curved surface and plane which has a plane surface. So in physics, whenever we start with a plane mirror or spherical mirror, because in ray diagrams we will be drawing them. So how to draw them in physics? So in plane mirror what we see, we draw a big line with the small oblique lines on it. So this is how you are going to signify the plane mirror in this chapter. And spherical mirror, we have two kinds of spherical mirror. One is like this, other is like this. They are actually the two sides of spoon, as you can see. That the upper side is called as the concave mirror, or you can say it just resembles the concave mirror. And the lower side is convex. The concave mirror is that in which the reflection occurs from the inner side and outer side is shiny and polished. So this is how you are going to draw concave mirror. And convex is that from where the reflection occurs from the outer side and the inner side is polished. So this is the convex mirror. So two kind of mirrors you will come across in this optics, that is the plane mirror, that means a straight line with small oblique lines. Spherical mirror is that which has a curved surface. Curved can be this kind of curve, that is you can remember this with the the above side of spoon. So the reflection occurs from the inner side and this is the polished surface, this is the concave mirror. And the convex one is that in which the reflection occurs from the outer side and inner side is the polished. That means the lower side of the spoon. So this is what is a plane mirror and a spherical mirror. Now depending upon the size of sources, that means what is the size of source, that we have a source from which the light is being emitted. So we depending upon the size of the source, we classify the sources into two kinds. One is the point source, other is the finite source. Not infinite, it is finite. So how you are going to signify point source in the ray diagram? We will just put a dot. So whenever you have a dot and the ray of lights are coming from it, so just this should click your mind that it is a point source. So you are going to represent it by dot. I am just putting the brackets here, not to use in the ray diagram, it is just to enclose this dot. And whenever you are talking of finite object, it is denoted by this sign, that is the arrow. So whenever there is an arrow like this and the light rays are coming from it, so that means it is a finite source. And one more important thing, like I have drawn this arrow, the pointer pointing upside, you also have to draw in the same manner. Don't draw in an opposite manner. Like if you draw like this, it means something else in the ray diagram. So whenever I am just talking about the finite source, do it like this, not like this. Because whenever you are pointing the pointer up or pointing the pointer down, it signifies different meaning in the ray diagram. So don't confuse in that case. Just draw a finite source in the same way as I have drawn in this way. Right. So these, depending upon the size of sources, I think it's clear that we have a point source which is denoted by dot. We have a finite source which is denoted by the arrow which is pointing upside. Now, what about image? We know that image is formed. You know that where the image is formed. Image is not formed randomly anywhere. It is formed at certain place and there should be a certain condition which should be fulfilled in order to form an image. See, image is formed where reflected rays meet or appear to meet. So the point where reflected rays meet or appear to meet is that point where image is formed. So depending upon that, we have two kinds of images. we see two kind of images. One is in virtual image, other is in real image. So what is the difference between two? Virtual image is that, first we'll start with the real image. Real image is that it is formed when reflected rays actually meet at a point. So when reflected rays actually meet at a point, the image is said to be real. Virtual image is that when reflected rays do not actually meet at any point but appear to meet. That means we hypothetically we assume that they appear to meet at certain point, but otherwise they are not meeting. And you must be thinking that what kind of definition I wrote for real and virtual image. Don't get confused when I am going, like, just do the points as I am telling you, but the time I will draw a ray diagram, these points will be more clear to you. So for this moment you should only know that image is formed at that point where reflected rays meet or appear to meet. So we have, depending upon that, we have two kinds of image. When reflected rays actually meeting at a point, that means there is no hypothetical situation, they are actually meeting at a point. So that image which is formed at that point is real. And when they are not actually meeting, they just appear to meet at certain point, they are said to be virtual. Real image are always inverted. That means upside down. Inverted means, suppose I have, suppose if I talk of myself, suppose I am standing like this, I am a source. So if my image is inverted, that means I won't be this thing formed in the same way. I will be formed upside down. That means legs up, head down. So that is something called as inverted image. So suppose this is my object. So if I say that it forms an inverted image, it will be formed in this manner. You just regard that this pointer is in head and this is a foot, let's say. So when it is inverted, that means you are going to see upside down. That means it is just inverted. But virtual image is always erect. Suppose if I talk of again of myself, if my image is virtual, then I'll see myself in the same manner. That means head up, legs down. But if my image is going to be inverted, then I'll say upside down. That means legs above and head down. So this is what you mean by inverted and erect. And moreover, you know that real image can be obtained on screen. We can obtain them on screen, but virtual image can't be obtained on screen. So whatever images whatever images we see in a cinema hall, they are all obtained on the screen. So that means they are all real and they are all inverted, and in them the reflected rays are actually meeting at a point. So those all images are real. Got it? So this is what is a real and virtual image. You will be more confident on this topic when we will discuss the ray diagram. When the time I will draw a ray diagram, you will be more clear with these points. Right? And one more question I would like to discuss with you, that is very important. You often get a question like this in paper. You get a question that what happens to a light which falls normally on the surface. So let's say this is my surface, and I told you that what happened to the light which falls normally on the surface. Normally means perpendicular. So there may be a word used perpendicular in the question, and there may be a word normally. So you should know that both of them means the same. So this is my normal ray. So they have asked you that what happened to this ray which falls normally on the surface. So you are just going to retrace its path, that how the reflection is going to take place in this case. So just look at the board carefully, that where it gets reflected, it just retrace its path. It just retrace its path. That means it is reflected along the same line. And in this case there is no normal ray, because it is itself perpendicular, and we know that perpendicular ray is a normal ray. So that means angle between the normal and the incident ray, or the normal and the reflected ray, is always obviously going to be 0. So if somebody asks you to point the angle of incidence and angle of reflection, you should be clear, as it is retracing its path. So obviously angle of incidence is 0, and we know that angle of incidence is always equal to angle of reflection. So that means again it is 0. This is very important question. You get this question for 2 marks in your paper. So this is what, when light falls normally on the surface, then what trace the path for the reflected ray, and moreover what is the value for angle of incidence and reflection. So you should be quick with an answer that it is going to retrace its path, and angle I and angle IR is equal to 0. So this is what is the basic thing which we'll be requiring in order to make the ray diagram. I think it's clear. Two kinds of plane mirror, you know how to draw them. You know, depending upon the size of sources, how to draw a point and a finite source. You know where the image is formed and what kind of images do we see, and moreover the important question which I discussed with you, that what happens when light fall normally on the surface. So now it's time to draw a ray diagram, because we are already done with the basic terms also and basic laws also, and about the mirror and the sources also. So we'll be just drawing the ray diagram now. So we are just going to draw a ray diagram for plane mirror. And what kind of source I am putting? I'm using a point source. So let's make first plane mirror. You know that we make plane mirror like this, a big line with the small oblique lines, and as I told you, we have a point source. So let's say this is my point source. Obviously, if it is a source, then many light rays would be coming from this. But whenever you are making a ray diagram, we don't have to mess up everything. Just make use of two rays. Just make use of two rays of different like the rays which are emitting. They can be a straight rays and they can be striking the mirror at certain angle. Only these two kind of rays you will be able to see from the source. So don't use many rays. Just use two rays, because minimum two rays are required in order to draw the ray diagram. So let's say that there are rays which are falling normally like this, and I'll write M because this is my mirror. There may be a ray which is falling at certain angle. So let's say this is point of incidence. Let's say this is also point of incidence. Now, as I told you that whenever the light falls normally, how it moves after reflection, we have already discussed it retraces. So that means it retraces its path. And what happened to this ray? We discussed here that when light falls, it gets bounced back, same angles. The same thing we are going to do here. So it gets reflected like this. Let's draw a normal ray. Let this is be normal ray. This is angle of incidence. This is angle of reflection. So can you see that do you see that reflected rays are meeting at any point? No, we can't see, because you see that one reflected ray is being reflected in this direction and other reflected ray is moving in this direction. They are not meeting at any point. But if we just produce them hypothetically behind the mirror, like if I produce this reflected ray behind the mirror like this, and this reflected ray is this, so if I just extend it behind the mirror, so it will get extended like this. So can you see that they are meeting now? Yes, we can see. Otherwise, in real situation, they are not meeting. This reflected ray is going in this direction and this reflected ray is going in this direction. They are not meeting. But when you are extending this rays behind the mirror, so you see that they are meeting hypothetically. So this is the image. This is the image. Now, what kind of image is it? Is it real? Reflected rays are actually meeting, or reflected rays just appear to meet? They are not actually meeting. So we see that in this case reflected rays are not actually meeting, they just appear to meet at certain point. So this kind of image is called as virtual image. I think you got it now, the difference between virtual and real. Real ones are those when reflected rays are actually meeting. Suppose if we have a condition when these rays are actually meeting, they don't meet actually in case of plane mirror. We will observe in case of spherical mirrors, but otherwise if we talk about plane mirror, they don't actually meet. But when you extend them behind the mirror, we see that in a hypothetical way that they are meeting at certain point. So that image is called as virtual image. And we know that virtual image is always erect. That means same. Like if head is up and legs are down, so the image will also have the legs head up and legs down. And moreover, what kind of thing you can see that plane mirror always form image of same size. that what will be the size of the point of source, that is going to be the size of the image. And moreover, the distance, if we see of source from mirror, is always equal to the distance of image from mirror. So I'll write, let's say this is m, so that means OM is equal to MI. That means this distance is equal to this distance. This is my I, this is my O, and this is my M. So OM is equal to MI. And moreover, we observe a certain another kind of phenomena, that the image formed by plane mirror is always laterally inverted. And like, have you ever seen this kind of image? Yes, we see in a daily routine. Whenever you see yourself in a plane mirror, the looking glass which we use at home to dress up is all plane mirrors. So that is the image which you see, these kind of characteristics you see whenever you are dressing up at home in the looking glass. So this kind of image is formed. So what you observe in that case, you see that you are erect, like if you are standing like this, you are going to see yourself in the same way in the mirror also. And moreover, you look like same size. Suppose if you are fat, you look fat. If you are thin, you look thin. If you are tall, you look tall. If you are dwarf, you look dwarf. So that means you look like same size. And moreover, the distance of object from mirror is same from mirror, distance of image from mirror. Suppose you have a mirror, and if you are moving towards the mirror, then your image is also moving towards the mirror. And if you are moving away from the mirror, at the same time your image is also moving away from the mirror. It's not like that if you see yourself in a mirror, you are moving away and your image is still there. It's not like that, right? It happens in the horror movies, but not in a real life. So whenever you observe yourself in a plane mirror, the distance of your, like if your object from mirror will be equal to the distance of your image from the mirror. And moreover, one interesting phenomena what you see is the laterally inverted. Now what is this laterally inverted? We call this phenomena as lateral inversion. What's that? It is that whenever you see yourself in a plane mirror, then your left hand side becomes right hand side, and your right hand side becomes left hand side. So this kind of thing is called as lateral inversion or laterally inverted, and this is a feature of the plane mirror. The plane mirror always show this kind of thing, that your left hand side becomes right and right becomes left. So lateral inversion is a phenomenon when let LHS becomes RHS or vice versa, when object is exposed to, or you can say object is kept in front of plane mirror. This is the specific characteristic for the plane mirror. So whenever you get a question like this, that draw a ray diagram for the plane mirror, so what you need to do is, there is no need of writing a big paragraph, just draw a figure like this, and don't forget to mention these 5 characteristics. These are very important. The ray diagram without the characteristics is an incomplete answer. So if you will draw a ray diagram, and if you will not draw arrow like this, as I pointed like this, then your ray diagram is just going to get cross. So don't do this kind of mistake. Draw a well labeled ray diagram indicating the angles, the normal ray, everything, and along with that you have to mention the characteristics also, because the characteristics are one which will make an examiner familiar that what kind of image you think about, that what kind of image this kind of mirror is forming, whether it is a plane mirror or it is concave or convex mirror, you need to do in the same manner. So this is what is the characteristics, and I think you got it. The lateral inversion also, it is a phenomena when LHS becomes RHS or vice versa. Vice versa means, like in a similar way, LHS becoming RHS, your RHS is again becoming the LHS when object is exposed to plane mirror. So this is what is in lateral inversion. Now we'll draw a figure, like as I draw a figure for a point source, I'll just make you draw a figure for the finite source also, because otherwise it is not included in your syllabus, but you must be thinking in your mind that what kind of image you will form for a finite object, right? So we'll just discuss now, just look at them.